The fundamentals of electricity. Electricity is the flow of electric charge through a metallic conductive medium such as copper, aluminium or silver, and always follows the path of least resistance. There are invisible fields of energy all around us, like gravitational, magnetic and electric. These are the ones that we know of, at least. An electron with a negative charge is attracted to and will move towards a positive proton. The potential difference of the electric field is determined by the strength of the electrical force. If 1 joule of energy is required to move 1 coulomb of charge through a component in a circuit, then the potential difference across these components is 1 volt, or 1 joule per coulomb. Voltage is analogous to electrical pressure. Now, the amount of coulombs flowing past a particular point in a circuit per unit time is known as the current strength, or amperage. This is analogous to electrical volume moving through per unit time. The measurement of the opposition, or the force against the current flow, is known as resistance and is measured in ohms. It can be almost seen as electrical friction. Your toaster has a lot of resistance, which allows it to transform electrical energy to thermal energy. Electrical power is the rate per unit time of which electrical energy is transferred by an electric circuit. This is measured in watts. Now, these 4 elements, voltage, amperage, resistance and power, share a mathematical relationship with one another, which can be observed through these formulae. In order for electrical energy to flow, there needs to be a potential difference applied within a closed circuit. And trust me, you don't want to be the one that completes this circuit if it's high voltage. So always wear safety gear when dealing with high voltages. Rubber shoes and rubber gloves should keep you safe with low-level voltages of residential circuits. Electrical components can be arranged in a circuit in the following ways. In series, this is where loads connect one after the other. Current and voltage will vary across the 2 loads or more, depending on their individual resistances. They can also be arranged in parallel, where there is a fork in the circuit where the same voltages will be applied on both components, but the current will also diverge according to their resistances, where the component with the least resistance will have more current flowing through it. You can also have a combination of series and parallel to form more complex circuits, but they can be simplified through Kirchhoff's law. Types of current patterns. Now, there is DC electricity, direct current. This is where electrons flow in one direction from negative to positive. Most of our electronics, like our phones and devices, uses 5-volt DC electricity. Then there's alternating current, AC, popularized by Tesla, where the electrons will alternate in their direction and vibrate in the pattern of a sine wave if you observe it through an oscilloscope. There are many reasons why we use AC electricity in our modern day grids. It's easier to generate, it's easier to transform from higher voltages to lower voltages, and vice versa. There are also less electrical losses to resistance across long distances on the pylons that we see. Your home's electrical circuit. Now, your home is powered by AC electricity at 50 Hz, or at least here in South Africa. That's moving back and forth 50 times a second at 230 volts. In some countries like Japan, it's 110 volts at 60 Hz. The cable providing power to your homes vary in 2 forms. In single phase, this is where a pair of 2-wire system, red and black, where a home is powered with 1 live wire and 1 neutral wire. The live wire is the source of the power, whilst the neutral is the current returning to the generator in the power station. And then there's 3-phase setups, where this is a 3-wire system that is used in larger power consumers such as double-story homes or even small factories. There are 3 live wires and 1 neutral. Earthing. In the event that appliances has a loose live wire and is touching a metallic body, if you touch that surface, it will flow through you, resulting in injury or even death. So that's why your plugs and appliances are connected to a ground cable, which provides a path for a fault current to flow to earth and or for an earth leakage detection breaker tripping, preventing any damages to the appliances or any unpleasant shocks. Now that we've familiarized ourselves with the essentials of electricity, let's dive deeper into the electrical laws that you should be familiar with. Number 1, Ohm's law. The strength of a current is directly proportional to the potential difference and inversely proportional to the resistance of the circuit as described by this formula. Number 2, Watt's law. The power of an electrical circuit is the product of the voltage and current. Kirchhoff's law. The sum of all the currents entering and exiting the node must equal 0. Faraday's first law. Whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. If the conductor circuit is closed, a current is induced, which is called induced current. Faraday's second law is that the induced electromagnetic field in a coil is equal to the rate of change of the flux linkage. Lenz's law. The current induced in a circuit due to a change in magnetic field is directed to oppose the change in flux and to exert a mechanical force which opposes the motion. Coulomb's law. The magnitude or the electrostatic force of an attraction or repulsion between two electrically charged bodies is directly proportional to the product of the charged bodies and inversely proportional to the square of the distance between the center of the charged bodies. Gauss's law. The electrical flux across any closed surface is proportional to the net electric charge enclosed by the surface. The right-hand rule. If you point your pointer finger in the direction of the and then your middle finger your thumb points to the direction of the magnetic force pushing on the moving charge. Alright, now some of these mathematical discussions I just shared might have flown straight over your head. However, there are tons of resources and tests online that you can further help you to understand electricity. I'll put a few of those links in the description. For now, we're going to be continuing on focusing on the basics of solar energy by moving on to our next chapter, how photovoltaic electrical generation system components are arranged.